Hey everybody, it's the Alarm Doctor here again. Today's video is on one of my favorite subjects as far as municipal telegraph systems go, and that's air horns. A lot of systems had air horns on them, mainly the volunteer departments. They were used to, of course, bark out the box number or call the volunteers in. They were used in conjunction with, a lot of times, house sirens. And so what we want to do today is go through these types of horns and see what makes them tick. Now, contrary to most who believe that the diaphone was the only type horn used for municipal telegraph systems, that's not correct. They also sold what they called a Type F horn, which was a diaphragm air horn. Similar to the same horn, only much larger, that you find on commercial trucks. So what we're going to do today is go through these two types of horns. On the left is the Type B diaphone, sold exclusively by Gamewell. On the right is a Type F air horn, or diaphragm air horn, which was not only sold by Gamewell, but other municipal telegraph companies. So let's take a look at them, see how they're the same, see how they're different. Okay, the first horn we're going to talk about is the Type F, or diaphragm air horn. Now, these are very basic in design. This is all a single casting. This is the projector. This is where the sound's produced. This is a meter or a gauge port. And here's the inlet. And this one has mounting tabs on it. Some of the smaller ones, the only thing that holds them is the piping. Now, if we come around here to the back side, you can see the inside of this horn. Now, what we have is, how this operates is the air comes in through a port right here. It pressurizes this section of the horn. The diaphragm is flat against this face right here. When the pressure overcomes the tension of the diaphragm buckles or vibrates, allows the air to come through and go out through the projector. That's what produces your tone. Now, here's one of the other parts. This is the diaphragm itself, and this is the retaining ring. Now, usually on diaphragm horns, the size of the diaphragm dictates the tone. In other words, the larger the diaphragm, the lower the tone. Now, according to most manufacturers, they didn't want you to use a horn that had any smaller than a 4-inch diaphragm in it. Another way they made these have a distinct tone to them is they would use two horns together, and it would create a harmony, usually one pointed one direction, one pointed the other direction, and that harmony in horn lingo is what they call chiming. So basically what you could do is, of course, the diaphragm had a lot to do with the tone. Also, how tight you put the ring on. The tighter the ring, the higher the tone. So you had one adjustment at least as far as changing the tone of these horns. These were made by several different companies. Federal, the siren guys, actually sold a horn. Horn-Eye, Safa, Gamewell, of course. And a lot of them had their company logo cast in the side. Now, whether they actually produced the horns themselves or had somebody produce them for those companies and put their name on it, that I really couldn't tell you. Now, what makes these horns fail? Well, here's the main thing that makes these horns fail, and you can see it on this particular diaphragm right here. It's cracked. That's the main reason that diaphragm horns fail. These things flex hundreds of times a second to produce the tone when the air is put through them. And eventually they fatigue and they break. So this is the main reason why these type horns fail. And you'll know it right away. You'll hear hissing sounds out of the back of the horn. It'll just sound awful. And so you have to get a replacement diaphragm. Now, these big older horns, there is a company in Washington State, and I'll post the website at the end of the video, that makes diaphragms for these horns. This particular horn here is made by Cunningham. Another horn company that you see quite a bit of in municipal systems is Clark Cooper. And this company can produce replacement diaphragms for this type of horn. Okay, up next, the diaphone. Okay, now we're going to talk about the diaphone. The diaphone has a lot more parts than the diaphragm horn. Now, of course, this is the horn projector. Real early models of this were copper. Later models were galvanized steel. And here's the center section, which produces the sounds where the air comes into. It has a back plate, and also there was actually two different designed pistons for this horn. One piston was a high tone piston, one piston was a low tone piston, and you can see it's pretty obvious the difference in design. So let's see what makes this thing work. This particular horn here is a newer version. As you can see, the tag has Gulf Western on it. The easiest way to tell a really old diaphone is this ID tag on the top. On the very old ones was large, and it was cast. And it took up almost the entire width of the cylinder body, and it was probably about 3 inches across. When we talked about the pistons, you can see there's two different designs here, and these are both aluminum. Some of the very, very early horns had brass pistons. One of the other pieces of information about diaphones, this is not the only size that was made. There was actually 3 or 4 different sizes, most of them larger than this one. Those were mainly used in foghorn situations, lighthouse foghorns, and actually that's what these were originally designed for. Okay, in this section of the horn you see, of course, this is the inlet right here, and these horns are actually a little bit complicated. Also right here, this is a gauge port. But if we tip this horn up so you can see down on the inside, you can see the outside body is cast. It has a pressed in bronze cylinder section. Now, as you can see, if I zoom in here a little bit, there are air ports and all types of channels for the air to travel inside this cylinder. These slots up in the front, the smaller section, air comes out of these. Air comes out of these ports, and there's actually some channels right along this back side that air comes out of. Why all the ports? Well, the reason is this horn has 2 operating sections. The motor section and the sounding section. Okay, I'll try to explain briefly. The rear part of the horn is the motor section, back here. These channels, air channels, etc., flow through cuts inside this brass cylinder. And what it does is it causes the motion of the piston. The air traveling through causes the motion, the vibration. And again, this is hundreds of times a second. Now, the section that produces the sound is in the front. And this basically works like this. As you can see, sorry it's hard to see, but there are air channels. There are also air channels in the piston. So what happens is the air is forced into the sounding section also at the same time as the motor section of this horn. And when this piston vibrates up and down, it chops the air. It opens and closes these channels and chops the air. And when it does that, that produces the sound. And then of course that sound goes on out the projector. Gamewell's claim to fame on these horns was the fact that they had a very distinct sound and could not be mistaken for boat horns, trucks horns, etc. And this chopping action is the reason why. On a similar note, it may be something like the stutter tone horns on a fire truck. The way this moves up and down and chops the air, it creates that tone. So, there again, we talked about tone again. Here's something that I wanted to bring up and show very simply what high tone and low tone does. Now, Drew, forgive my artwork here. The top horn is a higher pitched or higher tone horn. Now, if you know anything about sound waves, the higher the tone or the higher the pitch, the shorter the sound wave. So as you can see, this high pitched horn, the sound wave comes out and it runs into this tree, building, house, whatever you want to call it, and gets partially absorbed because of the length of the sound wave. Now if you go to a lower tone horn, the sound wave is much taller. So as you can see by this simple picture, it has more of a tendency to go over items. So the sound is not absorbed as much by trees, buildings, hillsides, etc. So normally on outside public warning devices, the lower the tone, the more distance traveled you're going to get out of your sound. Okay, let's talk real quick about why these fail. One of the biggest culprits is foreign objects. Now most of the piping, the mounting flanges, etc. for these horns have brass screens in them to catch larger particles of dirt, any corrosion or rust that might have got caught or blown up through the piping, to prevent jamming of the piston. So that's one reason they fail. The main reason that diaphones fail is wear on the pistons. Now as you can see, this piston right here is pretty well worn. It doesn't take more than 3/1000ths, 4/1000ths wear on these pistons and you start having problems. They don't want to vibrate, they want to get stuck. You know, you see a lot of guys talking about, oh well, you know, Gamewell recommends 35 psi on these horns, but we run ours at 45, 50, 60 pounds. Well, yeah, they sound different and they sound good at that particular air pressure, but they also wear the pistons out faster. And that was the idea. I think that was the happy medium that Gamewell came up with as far as pressure, sound and longevity of the pistons was that 35 psi pressure. So this is kind of a quick oversight of these horns. I hope you learned something. I probably caused a lot of questions also. There are a couple of good websites to learn more information about these horns. One is the Diaphone website. It's dedicated to diaphone horns. And also there is a horn and whistle board forum that has both the type F or diaphragm horns and the diaphone horns, and I'll post those websites at the end of this video. So I hope this helped you out a little bit. It's interesting to me. I love the sound. And until next time, this is the Alarm Doctor. See ya.